Hello? Okay, great. You can hear me. Welcome to this talk on designing applications that use LLMs, large language models. I am Marie-Elise Blete. I work at Worldline. Do you know Worldline, please? No? Okay, not many people here. But for those of you who don't know Worldline, you have actually been using our services without knowing for perhaps many years, because we're the leading payment company in Europe. So every time you pay, well, you're probably using our services. And at Worldline, I work at the R&D entity, and I'm in a team that is specialized in AI. I'm not a data scientist. My colleagues are. They are researchers. And I am the software engineer here to bridge the gap between research and real-world applications. I haven't written a book on this subject. I have 5 here to give away to people. If you are interested, please come and see me after my talk. So this morning, if you paid attention to the keynote, you might have seen this guy. This is Tim Berners-Lee. So he's a British scientist, and he invented the World Wide Web in 1989 here at CERN. And there's one thing that is important, or I find important, is that his invention was supported by 2 key technologies. The first one being the hyperlink, and the second one being the mouse. I have one here, so it probably not the one that he used, but this is mine. And the mouse was the first revolution in human-computer interaction. And it's said that LLMs today might be the new, or the computer mouse of this generation. So the idea of this talk is to put that to the test. So I'm going to share with you some experience that I made, and we are going to try to replace clicks by conversations. Before I dive in, I need to go a little back to basics to make sure we're all on the same page. So the underlying principle of a mouse, you click it. For LLMs, it's generation by next probable word. So you have a smartphone. Your smartphone, when you write the text, it predicts the next word. LLM, same idea, except it's much more powerful. Second difference with my mouse is that LLMs are not deterministic. And that's something that we need to have in mind because it's by design. So for some open source models, you might be able to make some change, but most of the time it won't be possible. So that's something important to have in mind when you are working with LLMs. To get started, I have five concepts, 5 keywords. First, models. There's the model space has exploded in the last couple of months. Globally, there's 2 different types of models: closed models that are available through an API, and models that you can deploy yourself. So closed ones, you have Claude from Anthropic, for example. Of course, OpenAI, that I'm guessing you know. Gemini from Google. And for deploying it yourself, you have the Llama models from Meta, Mistral, you have Falcon models, and many, many more models that are available on Hugging Face. I'm going to stick with this one because this is the one I know best, but I'm really going to use the basic features of the API so that you can reproduce what I'm doing with any model you wish to use. So models have different capabilities and different price points. GPT-4 is 20 times more expensive than GPT 3.5 Turbo. So we will try to stick to this one when we can. If not, we'll go to GPT-4. Prompt completion and context. So prompt, it's easy. It's the input, completion, the output that we get from the API. Hello world, how can I help you? You may notice that this is in conversation style, so it's not exactly what I told you just before when we are predicting the next word. These models have been trained to work in conversation style. If I ask a question, what is Vox discern? I have this very verbose output. I truncated it because it was too long. If I want to continue the conversation and say, for example, how can I attend? Well, it won't be possible because the model is stateless. That means that OpenAI does not store for you all the messages that you sent before. So to do that, to continue the conversation, I actually need to send all the messages and all the answers back again. So once more, that's just something that we need to have in mind when we are going to design our system. And this is usually what we call the context. The context will be all the information that we send to the model. Perhaps we are going to have more prompts that are not here in the conversation to start, and so on. So context, globally, all the inputs. And last one, tokens. So this is a completely random sentence. Tokens is important because it's how the models predict. So I was saying that the model predicts the next probable word. It's not exactly true, it's more the next probable token. So why do we need to have this token notion? It's because it's how the API, the OpenAI API prices the usage. So for example, this sentence is 10 tokens, and it will cost $0.00010 to process as input for my API. With GPT 3.5, yes. This is what looks like the official library, the official Python library. I'm sorry, I know we're at Vox discern. I was once a Java developer, and I have actually been programming in Java for more than 10 years. And when I joined this AI team, well, I was first in denial, but I had to accept that I had to work with Python. So all my code is in Python. I think you'll still be able to understand what I'm doing. So don't worry. This is the answer. There's lots of information here, but what is interesting for us here is that it's the assistant, the role assistant and content. Hello, how can I assist you today? So there's one thing here that I just said. There's a role. So globally, the role just serves as a tag in the conversation to tag flag who is who, what is what in the conversation. So the assistant is the AI, and the user is the human. So that was a bit long introduction. Now let's go to the problem statement. So like I said, I was a Java developer for more than 10 years, and when I started, my first project was a project for the French ministry. It was the vehicle registration system, where it's just globally the system that manages all the registrations for everything that goes on the roads, all the cars, trucks, and so on. Very, very complicated system. We had many, many forms, many, many clicks, many, many buttons. And at one point, we had to add more buttons and forms to this, so there was no more space, so we added some pop-ups, and somehow things went astray from there, and we had pop-ups of pop-ups. Does that ring a bell to anyone? Yeah? Okay, so I hear some people laughing. Well, I'm sorry, I'm not going to solve your problems, I'm just going to create new ones. What we are going to do is, so when I heard this, LLMs are the new mouse, I was thinking of this particular application, and I told myself maybe I can try and change it and use LLMs instead of buttons. So I'm not going to rewrite everything because we were more than 13 developers for many years. I don't have the time to do that. I'm just going to imagine a simpler system that manages registrations where you can do 3 actions: register a new one, update one, or delete one. And a registration has 3 attributes: a model, a year, and an owner. And every time we do something, we want the user to confirm it. So it's very simple. And we want to change this to go from this clicks to this conversation, where we have everything, well, becomes only a simple chatbot with an assistant that can help you. To do this, I have 3 solutions. Of course, we're going to start with the first one. Very, very basic approach. We're going to describe everything in one prompt. So it's basically you open ChatGPT, you describe everything, and then you talk to ChatGPT as if it's the assistant to your car system. So to write this prompt, I'm going to use some prompt engineering tricks because the prompt is going to be complicated, and I'm going to separate this prompt into 4 parts. First, easy, give some context, very simple part. Next, I need to set the output format. Why do I need this? It's because I have 2 types of output. I have the output for the user. It's the conversation, hello, I'm an assistant, give me more information, and blah, blah, blah. And the output that is for my application. And this time, I want my LLM to be able to do things like execute this Python function. To do that, I decided to use a Python format. Sorry, not Python format, JSON format. So I'm fixated on Python. JSON formats, where the output is the output meant for the user, and function args are the outputs for the rest of my software application. So this is the prompt. I'm not going to read it to you, it's a bit long, where I described this output. Next, give precise instructions. So that's where the real value of the application will be. It's here, I will describe everything that can happen in my application in just plain text. So this is difficult. I'm a coder, I don't write specifications, but I'm guessing this is what it's close to specifications. I cut it on this slide because it was way too long, but yeah, you get the idea. And last part of my prompt will be, okay, off you go. And also remember about the JSON, because this is very important. If the output is not JSON, then I won't be able to parse it, and my system will just crash. So how will it look like? The first message in the conversation will be my big prompt. Next, the assistant will answer, hopefully using the JSON format. And then the real user will say, hi, I have a new car, and so on. And then there's going to be the conversation. And at the end, I want this kind of output. So with the function create registration and the correct arguments. So one thing we need to have in mind is that for the first message, we're only going to send 1 message. For a second, we're going to send 3 messages, and so on. So the more the conversation gets going, every time the user says something else, it's going to be more expensive because we are going to send everything. Time for a demo. Okay. Where is the, okay, the screen is here. Maybe I can zoom in. Okay. So here, let me see, I think I'm going to use GPT-4 here because 3.5 for the test I did, it was not powerful enough. So I'm going to go Python run. Okay, that was not it. Python main. Yes. So it's starting. And Yes, it works. I have internet. So this is live. What you can see here is in green, it's the actual JSON, and in white would be the real front-end exchange. So hi, I can say I have a new car. Okay, it's a bit slow. Oh no, okay. So the assistant is happy for me. So I have a car, Citroën, and the year is 2005. And I'm forgetting my name on purpose to see what happens. Okay, so it's asking for my name, nice. The name is Blete. Now it should ask for confirmation, and it did not. Okay, demo effect. So it forgot the confirmation. So this is the proof that LLMs are not deterministic. Things are not always happen as you expect. I'm going to update it. So like I made a mistake. Okay, the name is Smith. And what did... Okay, and once more, it forgot about confirmation. Thank you. Ah, yes, okay, sorry. Okay, I read it, okay. Okay, so it's asked for it, so yeah. It asks for a confirmation, but it uses the function at the same time. And that is not how I expected it to work, correct? So it's half a failure, I'd say. Okay. Let's go back to my slides, if I can. Yes, demo. Okay, that was in case if I didn't have any internet access. In this example, it worked. So, second solution. What are the issues with this? Well, first, it's not very scalable. You can easily imagine that if my system is more complicated, then my prompt will be huge and very complicated to manage. It's difficult to maintain, and globally, I don't trust it because it's completely black box for me. I need more control. Globally, the system, as is, it looks like this. I give all the instructions at the start. I have the discussion, and at the end, I have the action. What I would like would to have smaller instructions, at different points of the discussion. To do that, I'm going to use a state machine-like approach, where I have the user's input and my chatbot's output. I have states. I'm going to create states that will be steps in the process, and I will create a transition function. So this function will actually be a call to the LLM given a state and a prompt. So this is how I define it. So for example, I start my flow here, I'm in the start, the user will say, I have a new car. I will call the transition function, and my LLM will understand that I need to go to the new state. Then here I will have the discussion with the user and the LLM, and I will stay here until the LLM has all the information. Then I will go to the confirmation state, and yes or no, I go back, or I go to execute the action. And I do the same for the update and delete actions. So my diagram, this is what I'm going to implement. I'm going to create a starting prompt, which is this time much more simple. It's basically the first aspect of you are an assistant, and then the output format. And then I will have the transition prompts, and here this time the transition prompts will be where the real intelligence will be. So here I describe all the actions, and I describe how I go to one state from another. This is the example for this new state. And time for another demo. And let's see what happens this time. Oh, sorry about that. That was not what I wanted to do. Okay, number 2. here, I'm going to zoom in again. I'm going to switch to 3.5 and Python main. Maybe one more. Okay. So here, this time in green, I have the states. So hi, I have a new car. Okay. Nice. It's Citroën year 2005. Okay, so this is 3.5. You see it follows the instructions, but it's not that smart. So something is wrong here, but it's following the instructions where it really is asking, is it correct or not? So no, I'm going to say no. The name is Blete. Okay, Blete. Okay, and this time, so Citroën 2005 and Blete. Yes, it's correct. Thank you. So this time, so what you can see is it's not so smart. For example, it's owned by owner name in between brackets, so we see it's not that great. The conversation is a bit weird, but it really follows my instructions. I know I can trust it better. Okay, let's go back. And okay, yes. So here, the advantages of this one is that I can trust it better. And the LLMs are really used for what they do best, meaning natural language processing. And I can add rules here. I can make a complex diagram with intelligence and not rely on the intelligence of my LLM. And so this one, I can run it with 3.5, and it was not the case with the first one. So that's what I just said. And of course, there's also this one, is that I can separate my applications. I can separate my code in little bits and do some sort of unit tests. Whereas for the first solution, it was much more complicated to do that. Now let's go to our third approach. What I want to do is use agents, because I've heard of agents, I think it sounds cool, and I want to try it out. Let's see what happens. What is an agent? So an agent, it's a piece of software that can perform actions. So simply, it can call other code, it can execute code. And it can see, it can, you can give it feedback, so it sees the results of its actions, and it can adjust its actions accordingly. And what is important is that you give it goals and you give it abilities. We'll see, I'll explain more into details what that means. So I'm going to use the LangChain framework here. I'm not going to go into details, especially that there's Lisa given a talk about LangChain 4J. What I'm interested here about LangChain is simply the fact that it's easy to create agents with it. Globally, it's just prompt engineering, complex prompt engineering. So for the goals, I write a prompt to tell it what it's supposed to do. So it's supposed to have the conversation with the human and do what it says. And for its abilities, I make it able to answer back to the human and also access some tools. What is a tool? I define it like this in my Python code. This create registration tool that you see here is an actual function, Python function that exists. So what I'm doing here is that I'm making it available for my LLM to call and execute. And what is important is this description. So before let's say the business logic was in my transition prompts. Here, this time, the business logic is really in the description of these functions. And this is what the user will be, well, this is what the LLM will use to know how and when to use the function. And time for a demo again. Okay, no, that was not. If I do this, yes. Okay, and I want this one. I'm going to switch back to 4 because there's absolutely no hope for 3.5 for agents. It's really too complicated. Okay, so Python main. Is it big enough? Do you see the screen? Yeah. Okay, so this time it's a little different. I did a little web interface that you can see here. So this is made using Gradio. Gradio is great for demos. Do not use it for anything else, please. So again, I'll say, hi, I have a new car. And we have, so on the left here, you have the logs from LangChain, and here you have the chat. So that's okay. Okay, this is the worst demo that ever happened to me. I did this talk quite a few times, and this is the worst that happens. Okay, well, okay, great. What you can see is that you have the logs from the LangChain, and you see what the model is thinking. So here it got mixed up and is speaking to itself. Okay. Okay, I'm going to try again. Maybe, I think I did it clear, yes. I'm going to try again. This is just too bad. I have a new car. Ah, okay. So, okay, nice. That's better. So you have here the output, and you see what the agent is actually doing. So you can see the actions and the tools that it is using. So I'm going to do the same thing again. In year 2005. So, okay, so it's following the instructions correctly. The name is Blete. And confirm, okay, yes, so everything is going smoothly this time. And okay, great. So I have a new car, and it's AA123BB. So I didn't mention it, but there's no backend here. I have a dummy code that just sends all the time AA123BB. I have some time. I'm going to update it. I want to update it. Okay. Why? Yeah. That's why you don't need. You don't want to use Gradio for productions. The name is Blete. No. Okay. Nothing, that was not what I wanted to do. I wanted to write Smith. Let's see what is going to happen. Yeah. Okay. Yeah. The new name is Smith. Yes, confirmation. So that is working correctly. Yes. And great, so it's updated, and that's what we wanted to do. So all these examples, I'm going to provide the GitHub link. If you want to play with it, please do. Okay, Yes. So, results of this. The one being prop solution. I have the state machine solution and the agent solution. This one, it's good if you have a simple use case. I would recommend start with this one and see what happens. This one is, I think, is very interesting because from my engineering perspective, I'm more confident because I have more control over it. And the good news is it works with less powerful models. Especially if you plan to using, for example, open source models, this might be interesting. But of course, it can get complex. And agents, well, it's powerful, but it relies on a framework that is evolving a lot. It needs a very powerful model, and even sometimes it doesn't work, as you just saw. And it's going to be very expensive. So this is, you have here the link of the GitHub. Now, this was all small experiments that I did on my free time. I have here some feedback I would like to share with you that on real projects that we are working on with my team, where we try to go from really proof of concepts to real projects applicable, in production. Issue number 1. If you have worked with prompts, you know this feeling. Prompts sensitivity is a nightmare. You change a word, you change sometimes a comma, you change the orders of your sentence, and it just is not working as expected anymore. Best practice, track your prompts, add some metrics. I have added on these slides, I have some links. So this one is not exactly the same use case, but I think it's very interesting. It's one of my colleagues who wrote a blog post with metrics for tracking LLMs when you integrate them to your applications. Issue number 2, this one. I have a non-deterministic component in my application. How can I prove that my solution works? Because before, in standard applications, I write some tests. I say, okay, I've got this test coverage. Believe me, it works. Here, I can say, okay, I did many tests, but it's not deterministic, so I cannot guarantee that by doing the exact same thing, we'll get the exact same results. Well, you can't. And that's a real issue. It's a real shift, a real difference. You need to change your mindsets and integrate it differently than you would a normal component. What you can do is try to prove it should work most of the time. So, add tests, of course, or add guardrails and control loops. Guardrails, try to avoid things like this. This is something that you can do with my code. If I say the bundle is blue and the name is SP95, it's obviously completely false, but my code will accept anything from the LLM. Do not do that. Control the outputs from your LLM. Control loops. So this is adding more calls to the LLMs, but this time with a different role. So this is the example of chain of verification. You have your assistant, and then you have another LLM. It can be the same, but just you give it a different prompt, and its role will be to check that the assistant is correctly following its prompts. So you can have chain of, there's many other patterns like chain of thoughts, chain of whatever you like. Just the idea is stacking LLMs, making multiple calls with different roles to make it, let's say, stronger. And if it doesn't work, it's always good to have a fallback solution. As you could see here, I had a clear button and retry, that worked. And of course, adding an alternative. Here again, once more, a nice link from Microsoft with guidelines for human and AI interaction. There was a retry hidden in my code for the JSON part, because sometimes the model forgot about outputting in JSON and my system would crash. So I just did this, try 5 times to be sure it's in JSON. It worked. It's not a good idea. the best practice would be to use a model fine-tuned specifically to output JSON, or fine-tune it yourself, of course. But sometimes retry is better than nothing. Issue number 3, prompt injection. This is a screenshot from Bing. I think you have seen this kind of thing, where Bing disclosed that its codename was Sydney. On my side, I tried it on my application. I said it was supposed to act as Yoda. Well, it worked. That was from Tevox. I asked on Twitter for someone to try it and do some prompt injection, and that was his idea. It worked also. But so my system was not very robust. But this paper here has proved that there's no such thing as completely robust LLMs. They have managed to hack all publicly available LLMs when this paper was written, and make them output some plan to destroy humanity. So for me, there are 2 types of risk: reveal internals and change behavior. First one, will make sure that in your prompt that you don't have something like you have a codename and you must not reveal it. There's no point. Make sure that the LLM does not have access to information that you don't want to be disclosed. And for the change behavior, then this is more difficult, especially when you're doing an assistant, like my use cases, because the LLMs has access to functions that can modify my database. So here, it's a real issue here. The idea is really to make it as close as possible to make the LLM will interact as minimum as possible. You can also add some checks from the input and output. Like, if you know that your user will only need a few words, don't have a whole paragraph possible of inputs, because the more space you have, the more easy it is to do some prompt injection. You can also add some checks. What's also a good practice to add some text after your LLM's output. Globally, validate the format, the length, analyze the intent. You can also run the user's prompt to check if it's not malicious. And of course, monitoring is always a good idea. Issue number 4. What about costs? Okay, what about costs again? Well, good practice, limit conversation length. Every message from the user is going to cost more and more and more and more. So don't make the user try, if you know that the conversation should be over in 10 messages, then don't let the user talk for 100 messages. You can also summarize the conversation. This is actually very simple to do. So once you have, let's say, 10 messages, you can extract everything that you need and sum it up in one message, and then continue the conversation from the LLM's point of view from there. And this is going to save you a lot. And of course, it's always a good idea to use a cache. If you have some queries that you know are going to happen over and over, you can cache them and not call the LLM. But you might have noticed that all my solutions for 2 and 3 was call LLMs, add more prompts, and pay more. So here, there's a balance here to be found between all the risks that you are willing to take, between the hallucinations, between the prompt injection risks, and the costs. And then there's issue number 5. It's probably the issue that we should have started with, because I have lied to you since the beginning. This whole project is a very bad idea, because we're sending very personal data to OpenAI. Don't do that. Or, make sure that you are allowed to do that, especially if you're in Europe and you're sending data to the United States. Yeah, be careful here. So to sum it up, it looks very easy, having free couple of prompts and I have something up and running. But as you saw, it does not always work, and globally it's very, very challenging to have something, to go from the proof of concept state to something that is really usable in production, where you're sure that your clients would want to use it. It's also evolving so fast that it's very difficult to keep up, both in terms of landscape, in terms of techniques, in terms of models, everything. And I have the feeling that it's still in sandbox phase. I know, I have seen many companies go, okay, we're going to build our own chatbots, and then some months after they say, okay, no, we cannot put that in front of a client, it's just too risky. But it's definitely very promising. This is a quote from LangChain, so it's the AI heads at Meta. He says over and over in his tweets that LLMs are stupid. I think the idea here is more than that LLMs are tools. And just like the mouse, it's up to us to make something smart out of it. And just so that you know, there's a animal shelter for computer mice here at CERN. So maybe I'll give them mine. I have 4 minutes for questions, and you have all my pointers here, the GitHub link, and yeah. Thank you. Yeah.
Yes, I'm the project lead of Druze, which is the rule engine of Red Hat. And I wonder, I find these technologies very complementary to our rule engine, which probably is the solution number 2 that you were suggesting. So you control with a rule engine the different state, and then you can also do some cleanup of the input and the output and use the LLM in the middle. Have you ever experimented with mixing an LLM and a rule engine?
No.
Some solution in this direction?
No, I haven't, but that's just exactly what I had in mind with this state machine, like where you can really mix code, because having full LLMs, I think it's not possible. Just really, I think it's a nice solution because it allows us to mix code with rules. So I'm at the R&D department of my company. I have suggested this idea to different teams. Some have picked it up. I don't know the results though. I'm sorry. No more questions. And well, thank you very much.